lecture number 4. In the course of 8 lectures, we discuss open source best practices. We're interested to know how to be effective in open source projects, how to create those projects, how to contribute to them, and how to maintain them, how to make sure that the community grows, and how to make sure that your contribution is appreciated. On the first lecture, we discussed the characteristics of open source community, how toxic it is, how difficult it might be to be there. We discussed how to communicate in the community, how to talk to people using digital conversations, and how to make sure that your messages are being delivered well and being perceived well, so that your information and your intent well understood. On the second lecture, we discussed how to report bugs, because open source and in general software development is largely about reporting bugs. Not so much, well, not only about writing code, but also and mostly and largely about criticizing the code that other people created or that you created before. And by this criticism, by reporting bugs, we are making the code better. We're actually building the code by finding the incompletenesses and imperfection inside the code. On the lecture number 3, which was the previous lecture, we discussed how you can contribute with the changes and how to do it in GitHub through pull requests, because GitHub right now is the primary platform for open source projects, and not only for open source ones. And pull requests is the primary mechanism of making changes to repositories. If you want to be important for the project, if you want to be valuable with your contribution, you have to learn how to make pull requests, how to create them, how to convince open source community or the authors of the repository, the maintainers of the repository, that your contribution actually does make sense, doesn't contain too many mistakes, and is worth being included into the mainstream of the source code. In this lecture, we talk about how to accept the changes, how to review them. It's going to be your job, if you participate in an open source repository and the project, to review what people are bringing to you. And I want to start with a very interesting quote by a very famous author who we all know and love. He said long time ago, actually way before GitHub was created, that these pre-integration reviews, they appeared because of the open source. Just in general, reviewing the code, this practice of reviewing the code was long before we knew about open source. It was long before GitHub was created. People were reviewing code which other people created. However, these reviews, they were happening so-called post-mortem. They were happening after the code was already written and committed to the source code repository. The teams, they were organizing some sort of sessions, reviewing sessions, where they were discussing whether the code is good or bad, whether there are bugs or there are no bugs, and they were making some conclusions after those reviews. We knew about this practice for ages, before GitHub started to become popular and before open source. However, open source introduced the practice of pre-integration review. When we review something which is coming to the repository before we decide whether this contribution is good enough to be accepted, or maybe we can reject it. So the practice of rejection didn't exist before. That's what the message is about. People were reviewing afterwards, after the code is there. In open source, we have to review before, because the changes are coming from the developers who are not very well connected with us. We just don't know them, to put it simply. We just don't know who is coming to us, what's the intent of these changes, and whether the quality is acceptable or not. We need to make a decision before we accept the code. That's where these pre-integration reviews started. That means that being in this lecture, you not only learn how to do review in open source domain, in open source projects, but also in other projects as well. Because this practice of pre-integration reviews migrated from open source world to the world of proprietary software engineering, to the projects where we know people, we understand who are making changes, but still we don't want to accept changes immediately. We want to take a pause to review for a second, to review for a few days, and only after that accept the changes. Open source triggered that. Open source taught us this practice. Open source told us, and in a hard way, I would say, that this is what we have to do. We cannot trust everybody. We must check before we accept the changes. And as usual, I will give you a number of recommendations of how to do code reviews better. You can take them, you can use them, or you can just listen to them. Recommendation number one, which is titled this way, which is quite controversial. I will give you two opinions in this, two opinions around this problem. The first one is raise issues, don't resolve them. It means basically that when the code is coming to you, when you look at the source code, when you look at the pull request, your job is to tell the author that you don't like the code. Your job is not to help the author to fix it. Your job is not to fix it. Your job is not even to explain too much about it. Your job is to reject. It sounds harsh. It sounds maybe very too strong about it. But like I said, it's just one opinion, just one side, which I agree with. There is another suggestion, which I'm going to give you as well in a few minutes, but let's first look at the first suggestion. You should be as strict about rejecting as possible. It should be part of your mentality. It should be part of your mindset as a reviewer. When you review the changes, your job is to reject, not to accept. If your job was to accept, we would not have you in the first place. If your job is to accept the changes, then I can just simply put a robot in your chair, and the robot will just accept whatever is coming in. So if I'm asking you to do the code review, or if you're just alone in the repository, still, your job is to reject with a reason, of course. Your job is to find the reason to reject. Let's put it this way. This is what you have to do. Find the reason why these changes must be rejected. If you can't find this reason, you did a good job. If you didn't find a good reason, most probably you did a bad job. Maybe there is no reason. Maybe. But it should happen only after you find 1, 2, 3 reasons. And then the author of the request removes those reasons, makes some additional changes, and only after that you say, okay, all the reasons which I found before, they were eliminated from the pull request. I'm ready to accept. That's how it should be in your mind, in your philosophy as a reviewer. This is what basically, not exactly this is what this phrase is about, but this phrase is about don't go too much about solving these issues, about trying to put yourself into the shoes of the code author. Don't do that. If you do that, you start thinking about accepting the changes, which is, like I said, which is not what you're hired for. You're hired, or you sit in this repository to reject mostly. And I'll give you a number of famous people who said something similar or along these lines. For example, this one that was said, I don't know, a long time ago, 50 years ago. The author says that the inspection, this is what we're doing. It was not code review at that time, it was inspection. So the inspection is not intended to redesign, evaluate alternative design solutions, or to find solutions to errors. It is intended just to find errors. That was the philosophy at that time, and it still is, in my opinion. So be the one who finds errors. And let me put it this way, if you didn't find any errors in the pull request, you are a bad code reviewer. You did a bad code review. Maybe you're a good code reviewer, but in this particular case, you did a bad code review. If there are no bugs found, if there are no corrections suggested, if there are no problems indicated, highlighted. If when I see a pull request and I see that there is an explanation of the changes and then the reviewer was invited and then the reviewer said, I like it, and the pull request was merged, I understand that there was no job of code review done in this particular pull request. We can just do it without a code reviewer. Always try to find the bug. And you know, sometimes in a few projects in my practice, we did it this way. We were looking at the pull requests and we were analyzing how many changes and how many corrections were suggested by the code reviewer. And by this number, we were judging how much money to pay to the code reviewer. This may sound, again, too harsh for you. This may sound like a weird approach to motivating people. But think again. A code reviewer has to find incompletenesses, has to find imperfection in the code suggested. The more imperfections are found, the better. Of course, there has to be a limit, because if you just pay for these corrections found, then the code reviewer may hold this pull request forever, suggesting more and more changes. So of course, there has to be some sort of a judge who would be able to jump in at some point and say that there's too much, so you're complaining too much about it. But we haven't seen this kind of abuse of the rule, where the code reviewer would find many changes for a long time. They were reasonable people, and they were finding 1, 2, 3 suggestions and corrections, and at some point they were saying, okay, enough is enough, we can merge that. But obviously 0 changes or 0 suggestions, that was a clear indicator of no money to be paid for the reviewer, and that was a good motivator for them to always focus on finding bugs. Another quote, which may be helpful as well. Here we not so much care about the quote, we care about the number which is given here. So they're saying that, again, it was a long time ago, no matter what is the language, no matter what's happening in the inspection, we find about from 7 to 20 defects per 1,000 non-comment lines of the source code. 1 to 5 staff hours, major defects. So one defect takes from 1 to 5 staff hours, and we find about from 7 to 20 defects for 1,000 lines of code. Maybe this information may help you to analyze how much you can find. So when the pull request is coming and you see that there are 100 lines changed, you know that this is the amount you can find in 1,000 lines. So if 100 lines coming, then how many bugs you can probably find? How many problems you can find there? Well, let's say from 0 to maybe 2, something like that. Well, from 0.7, so let's say it's 1. From 1 to 2. So they are there. Any software code has problems. Any changes that people make to the source code, they definitely make some mistakes. Your job just to find those mistakes. Focus on this responsibility of yours, finding troubles, making sure they are there. And of course, not only finding them for yourself, but proving that they exist there. This is your job as well. Like we said before, your job is not to help them solve the problems. Your job is not to suggest improvements and suggest how to fix those problems. Your job is to identify the problems, but of course you have to prove that the problems are there. So it's not just something like, I don't like your code. That's also not an effective code review. You shouldn't say it like that. You shouldn't say, I don't like something. You should say, this code, in my opinion, has certain problems, and then prove it to me. If I'm the author, then your job is to prove to me that there is a problem with my code. How do you prove it? It depends on the situation. Of course, the best way to prove is to is to make a link to some trustable source of information. Maybe a paper, an article, a book, a Stack Overflow answer, maybe an example somewhere. Show me why the bug is definitely a bug. Because in case of a pull request, we're talking about bugs which we cannot prove by running the code. And we're going to talk about this in a minute as well, like what to do when you see that there is a bug, when you expect this piece of code to fail in production, in runtime, but it doesn't fail right in front of you. It looks like the code which is supposed to work, but you expect it to fail. You believe that it's going to fail. What to do in this case? That kind of bug which is the most difficult to report. But as we're going to see later, we'll see that people usually find not that kind of bugs. I think we're going to see it in a few slides later. The proof of what I'm saying right now. Mostly people, when they do the code review, they are paying attention to the bugs which are related to design decisions, to code formatting, to code style, to the elegance of the solution, to adhering to programming practices, but rarely to the functionality bugs. Rarely people say during code review that this line of code is written wrong and it's going to fail in runtime. And I think we shouldn't do that. I think we shouldn't find that kind of bugs. We indeed have to pay attention to the quality of code, to the way the code is formatted, to the way the code is designed, to the way the design patterns are being applied, to the way this code adhere to our programming practices which we established in our project or in our company. This is what you do when you review the code. You pay attention that the authors are on the same page with the project. Let's say in this project, we all decided that we're not going to use Java programming language, let's say. And then the pull request is coming and the author is using Java programming language. You don't care whether the code works or not. You don't check it. You don't pay attention usually. You first pay attention to whether this is what we decided to do in this project. No, we decided to do not Java. Because of this, you say, please don't do Java, remove it from your pull request. Please get back to Python because we all use Python in this project, so no Java. This is what you pay attention to mostly. A few more numbers for you to understand what's going on with the pull requests, and this is quite fresh research, just a few years ago. It's interesting that to summarize this attitude, the philosophy of raising issues and not helping them fix the issues, there could be a negative effect about this, of course. If we're talking about open source development, then you will usually face the fact that changes are coming to you from people who you don't know and from people who don't care about you that much. These people, they're sending you pull requests because they want your project, your product, to get the functionality that they need for their work. In most cases, they're not going to contribute to you because they want to help you. They usually will contribute because they need something from you. So they're coming to you with the changes, you're getting these changes merged, you release a new version, they take this new version and they forget about you. This is what happens usually. And if you reject them with the changes, if you be too strong about that, if you be impolite, if you be very rejective, if you be very strict about finding imperfection in their code, then they very likely will just walk away, fork your project, make a copy of your project, make the changes over there, make their own release of their copy, and will never get back to you. You have to keep the balance. You have to be as friendly and as ready to help even though we just discussed that it's not your job to help, your job is to tell them what's wrong, but do it in a way that they will feel that you do it because you want to help, not because you're so arrogant and you believe your code is the best code in the world. That's why you're saying, no, I don't like your code, I reject it because you made so many mistakes. Go back, do your homework, fix the bugs. Say it in a different way. Say that this contribution is great, thanks. That's going to be your first message. When the pull request is coming to you, your first message is thank you for your contribution. Thanks for trying to help the project. Thanks for writing something for my code base. However, believe it or not, we're trying to make our code as beautiful as possible. And we here, fortunately or unfortunately, we have certain standards. So we have certain expectations about the quality of code. Your code, for some reason, is not in line with these expectations. We're not saying that this code is bad. We're not saying that this code is not worth being called a perfect code. But we have different expectations. We have different standards. That's the best approach always. Just compare your standards with their code and say, we are not on the same page. Could you please make sure that your code is on the same page with our code? In this way, you're not going to offend them. Even though they wrote some crap, it happens, some garbage. People write code very low quality. But usually they do it not because they're evil people, not because they want to hurt you. They do it because they have no skills, for example, or they have no knowledge about your project, or they have no idea about your quality expectations. So you can help them, you can educate them. This is my recommendation number 2. Imagine, again, don't forget that your job is to report issues and not to fix them. That's true. That's 100% true. But there is another side of this coin. While you do that, you have a chance to educate your contributors. You have the chance to help them become more knowledgeable, become more skillful, become more professional. If you see that they are not as professional and as skillful as you would expect them to be, as you think you are, because you love your code, you wrote the perfect code, definitely, obviously, they are not as perfect as you are. You have a chance to educate them. Let's see what people are saying about that. And these articles, these things which I quote now, they're way more, way younger than this philosophy of very strong and strict code inspections. This is what the world is seeing right now. So we are from very strict and radical people in software engineering, especially. We're moving to the world of people who are way softer, way more tolerant, way more intolerant to strict decisions. People may take your decision of rejecting their code with way more negativity now comparing to how they would react 40 years ago. They're just different people, just different mentalities of people. We are way more sensitive right now. And maybe because of that, the philosophy of software engineering is also changing. Look at what the next few quotes are saying. This one, for example. They're saying that what you should talk about in the code review, it should be the discussion, the articulation. I really love this word, articulation of design rationale. So you are supposed to say what your design decisions are. That's exactly what I just told you before, that your job is to make sure that we're on the same page. This is what they're saying, but in a more beautiful words. You articulate what is this project is about, how it is designed, how it's organized, why we care about this and we don't care about that, why it's so important for us how you name your variable, why it's so important that we don't use Java. You're not just saying don't use Java because this is the decision we made last year, but you articulate your decision rationale. Why this decision was made. Maybe you need to show some paper about this. Maybe you need to show some written document about your design. you articulate, you make it obvious. And when you do it in your open source project, you do it not only for this author, but you do it for all other people who may come to your repository later, and they will find this discussion and they will learn something from it. In open source, the beauty of open source is that everything is open and everything stays forever with the repository. All your discussions, all your conversations, they stay in GitHub, they stay in those tickets, they stay in the conversation protocol, and people may find your repository in 5 years. They open this discussion and they will understand what are the design decisions in your repository. So articulate, be open, be verbose, be as detailed about them as possible, because the dialogue is open. No matter what the medium, the main medium in GitHub is the pull requests and issues. But now we're talking about pull requests. People are bringing the code to you, you reject it. While you reject it, you explain yourself, you explain your design. That's an amazing opportunity for you to do it there. And don't try to make a crosscut and connect with the author directly and make the explanations directly, which is happening so often. In my practice, especially when people know each other, and sometimes people sit next to each other in the same office. The pull request is coming, I know who is sending the request, I know that this guy is sitting next door, so I will, instead of explaining in the pull request why I don't accept this code, I just stand up, walk to another room, and sit next to him and tell him what's going on, explaining him why this code is not good. We have a very good connection, we discuss, we still remain friends. He doesn't get offended by my rejection. He improves the code. Case closed. This is wrong. This is not what I encourage you to do. Because in this case, you lose all of this information for future comers to your project. And remember, in open source, you don't know who's going to come to you. You don't know who is the next person who will show up with another piece of code to your repository. You need to use the opportunity, this opportunity, when the bad code is committed to you, use this opportunity to explain what is good code in your opinion, what it means for your repository to have a good code. Imagine you're a teacher in this pull request and there is a student sitting next to you, in front of you. You should convince that student, you should explain that student, you should teach that student, you should educate that guy. And now the criticism of the mentality which I suggested earlier. Raise issues, don't resolve them. These guys, they are saying that this mentality limits the ability of the group to collectively solve problems and mentor developers. Mentor. Do we agree? Do we disagree? I agree. I agree that if you strictly, if you misunderstand this principle, then yes, you will really limit your ability to mentor developers. And it's important to mentor. It's important, like I said, to teach them. I'm not going to repeat it again. You got the idea. But they're saying that change the mentality, which I disagree with. I don't think we need to get rid of this mentality entirely, that we should start resolving issues. We should mentor, that for sure. We should teach those programmers, but we should not resolve issues. We should not break the wall between the reviewer and the author. That's very important to keep this conflict actual, to keep that not a fight, but this, how to say, a separation, a segregation maybe between the people who make changes and the people who review changes. There has to be a clear difference between these two roles. It shouldn't be just we are all together, make changes and review changes. In this way, you lose the strictness, you lose the point, you lose the motivation of the reviewer. If reviewer believes that his job or her job is to help developers and help them fix the issues. Definitely not. It should be a conflict. It should be the opposite objectives of these two people. These people may change. Today you review the code, tomorrow you commit the code. But while you hold this role of a reviewer, your job is to reject. Your job is to be the opponent. Your job is to be against the changes which are coming. Not in favor of them, but against. You should look at it critically and continue raising issues, trying to convince those people that there are issues, that you don't like the code, and there are good reasons for that, not liking the code. If you do that, in that way, you're going to mentor them. While you explain, you're going to teach and mentor and everything. Maybe maybe they mean that there's going to be a negativity in the team, which may happen if the team consists of. It's not about. I'm wrong. It's not about who the team consists of. It's more about. It's more about the spirit of quality, which either exists in the team or it doesn't. In some teams, I've seen that people care way more about their position, about their promotion, about their so-called soft skills, about their personal position against other people, and this attitude is being actively promoted. So not the one who is writing the good code, not the one who is writing the biggest amount of code, not the one who is making the most difficult fixes and changes to the code is being promoted by the one, but the one who talks too much, the one who is the most vocal, who is the most aggressive, who is the most friendly to other people, who is the most, who is the most visible person in the team. And people, instead of thinking about quality, they become thinking about being visible. And that's, in that team, of course, it's better not to put these authors and reviewers against each other, because they're going to turn, they will jump into fights, like really fights, because their primary objective is to win the position in the hierarchy, is to dominate other programmers by using, I don't know, voice, by using aggression, by using soft skills. In that team, yeah, don't organize that fights. Then in that case, in that teams, you definitely say, no, we're not gonna follow this mentality. Instead, we're gonna help each other. But I am in general against this format of management. I am in favor of management where some sort of meritocracy exists, where the bigger the merit of yours, the bigger the contribution of yours in the lines of code, in the amount of fixes, in the amount of pull requests, and the amount of important changes, the better appreciation you get from the management, the bigger the salary. And in this case, of course, having this opposition will only make the team stronger. And it's not gonna anyhow get any trouble for the mentoring. Let's take a look at the next quote. They say that, again, they are in the same direction, in the same philosophy. They're saying that even though the top motivation, which is driving code reviews, is finding defects, actually, the actual outcomes are less about finding errors. It's about this is what I said to you before. This is not about finding errors, something that doesn't work. It's about mainly small logical low-level issues. By these small logical low-level issues, defect-related comments comprise a small proportion and mainly cover small logical related issues. So yeah, that's what I said before. So when people do code review, they don't really try to find defects. They don't really try to check whether the code will behave in the wrong way in production. They mostly pay attention to the style issues, to conventions, to violating the conventions of repository. I believe this is the right way. I believe this is how it should be. You shouldn't try to run the code in your head. You shouldn't try to convince the author that this code in production is not going to work. This is not your job. This is the job of unit tests. This is the job of integration tests. And I will show you by example in a few minutes what I mean by that. But now a few more quotes, which are also interesting. Again, with the same philosophy, they're saying that we reviewers prefer discussion and fixing code instead of reporting defects. This is what's happening now. And this is what I try to talk you out. I'm trying to convince you that this is not the right way, even though this is what's happening. People in the code reviews, in the pull requests, they not so much report problems, they discuss and even fixing code. So they are trying to suggest the fixes, while it shouldn't be that way. Instead, you should be trying to take the position of an opponent. And opponents, they don't discuss so much. They show the problems. They convince the authors that they are wrong. They sort of report defects. What kind of defects they don't say here. But I think that reporting issues is the primary job, even though it's not what is happening. Okay, and now a few numbers, just some numbers, which may be interesting to hear. In this research, which was also quite recent, they are saying that in Google, and it's not only in Google, I think it concerns all software development, especially open source, the amount of corrections, the amount of comments which the reviewer will give to you depends on how long you work in Google or how long you work with this open source repository. We discussed that before. We discussed that on the first lecture, that people pay attention to who you are instead of what your code does or how your code looks. Unfortunately. Unfortunately, GitHub is very opinionated place, is very subjective place, and people very judgmental about who is making the code changes. And that's reasonable. When I do the code review, I don't have so much time to look objectively at every pull request that is coming to me. I review every day at least 10 pull requests, at least. Sometimes I review more. And each pull request, if I would review them carefully, would take 30 minutes of my time. Maybe 20 minutes of my time if I carefully review every pull request. And I don't have that much time every day. I have other things to do. And that's why I judge about the quality of this pull request by the information about the author. If I know this person, if I have seen good pull requests from this person before, I will pay less attention to the quality of the code and maybe even not find any bugs there and do a lousy review job, just accept it and merge it. Because I trust that person. And that's reasonable. It's just this discrimination is in favor of effectiveness of my work. Otherwise, I would just be totally blocked by code review activities. And I don't want to be that. I don't want to be in that trouble. Take a look at the numbers. They're saying that if this is the number of years you work in Google, this is the average number of comments that people are going to post on your pull request. In the beginning, when you join Google, you will get about 6 suggestions. Well, they probably count all comments there. I don't remember, you can read the paper. But it's going to be some reasonable number. So people will care about what you do. People will make suggestions. People will criticize your work. When you work in Google for 4 years and more, they will mostly blindly accept what you did because they're going to trust. You're going to build your reputation and they're going to trust you. Because of that, our recommendation is build your reputation. Invest into your reputation. Stay with one repository for longer. The maintainers of the repository, they will understand who you are, they will trust you, they will accept you faster. And now what I promised to talk about is what to do when you see in the code that the code is not going to work in production. So what do you do as a code reviewer? I told you before that you're not supposed to fix the code. You're not supposed even to try to run it. You're not supposed to even think about running the code. You are supposed to raise issues. This is a very popular question in open source community, whether the code reviewer should look at the branch which is coming with the pull request, check out this branch on a laptop and run the code in this branch and see whether the code works or not, when we have a suspicion about that. So let's say this is my repository, you are coming to me with the code changes. I see in the code that you did something wrong, but I can't prove it. It will be hard for me to explain to you why this code is not going to work. What do I do? My temptation. I check out, I run it locally, I see, it doesn't work. It raised an exception. So I copy that exception to you, I show it in the pull request and say, hey, it's not going to work. You're going to fix your branch. You change the branch, you send it again, or you push to this branch, you text me and say, I fixed that problem, please merge. And I'm looking at it and I'm saying, no, I'm going to check it again. I check out your branch again, I run it locally, I see the bug, I post you the stack trace, and I say, no, it's not going to work. This is a completely wrong workflow. Totally wrong. Don't do that. And let me explain why. Well, first, it's time consuming. You're not going to be able to do that if you have dozens of pull requests per day. Just forget it. But it's not the main problem. The main problem is this. Your job as a code reviewer is to protect the repository, to defend the repository, to make sure that bad code doesn't get in. But your job is not to do it manually, not to be the defender, but your primary objective is to be the guy who is in charge of defending the repository. And the best defender of the repository is unit tests, integration tests, static analysis, all the possible automated checks. The pull request is coming. I look at the pull request and I look at the reports from continuous integration checkers. And they're saying everything is green. So the code, the branch, looks acceptable. But I feel, my guts, they tell me that the code is wrong. Instead of trying to prove it manually, I understand that there is a problem in our checks, in the CI checks, in the continuous integration checkers. These are the defenders of the code. These are the guys, the robots, who are supposed to defend our code base. But they don't. They report no troubles, even though it looks to me that there are problems there. So what do? The right behavior is this. I say in the pull request, hold on a second, I'm not going to merge it right now, give me some time, and then I go to a bug tracking in the repository and I report the bug. And I'm saying there, something is wrong with our CI. The CI is not catching that kind of error, so we don't have enough unit tests. We don't have enough mechanisms to check whether the code is perfect or not. Please increase the protection. Please add more checkers, add more validators, add more unit tests there. That's what I do. Then what happens next? Somebody, maybe me, maybe somebody else, will open this ticket. Remember, the pull request is still waiting, open, not merged. Somebody will open that ticket, introduce additional checks, introduce additional protection to the repository, And then we're going to merge that additional protection. And then I go back to the pull request and I'm going to check this CI guys one more time. And in this case, they will show me, no way, this code cannot be merged. This branch is not good because of the additional validation which was introduced because of the problem I saw there. Seeing the problem in the branch motivated me to introduce new checks. That's how it should be. If I introduce new checks and they are still weak, they're still not able to catch the issues which are the bugs, the troubles, the problems which were introduced in this pull request, then I'm going to do it again. I'm going to introduce more checks. I'm going to introduce more automated tests until I will be able to prove to the pull request author that his code is not perfect. I'm not going to do it manually. I don't waste my time on explaining to the author why I believe that this code is not perfect, why I believe that it should be improved. No, I don't want to waste my time on one person. I want to invest my time on increasing the protection for the entire repository. That's why we don't run the code in the branch. We don't take it, we don't run it, because every minute you spend on that is wasted. Instead, you have to improve the protection of the repository so that tomorrow nobody will be able to send that kind of code again. That's the mentality. That's how you should think. So never do that. Never check out the branch. Let's talk about the reasons for rejection. This is a very popular debate. I think we touched that subject before. Your job is to make sure that pull requests are perfectly reviewed, that you were able to find the reasons for rejection, that you were able to understand what is wrong there and properly reject. If the pull request is big, it will be difficult for you or sometimes impossible to understand what has been done there and find a good reason for rejection. My suggestion, reject it because it's big. Don't even try to analyze. If you see that there are 50 different files being changed, don't review. Just don't waste your time. Ask the author, can you please break it down into 5 different pull requests and then send them to me one by one. Then I will be able to review. It is going to hurt the author, definitely. The author is not going to be happy. You can imagine how difficult it will be for the author to take that huge amount of changes and decompose into increments. But this is going to be the lesson which the author will learn for a lifetime, I hope. I've seen these situations. Usually they happen with immature, young, junior developers. They believe that it's very good, it's very productive to create massive amount of changes. This is what makes them good programmers. Because look how many changes I've made. Look how many files I changed. I fixed all the problems at the same time. I fixed this problem, that problem. I fixed 5 different bugs which were reported in 5 different tickets, and I send it all together. You just need to click one button and all problems gone. What do we do with these junior developers? We teach them. We teach them the lesson the hard way. I suggest you do the same. And a few quotes which are related to this subject, a few numbers coming from different companies. Well, of course, this one is very famous, which I decided to put here into this section. Eric Raymond says that good programmers know how to write, but the great programmers, they know how to rewrite and reuse. This is related to the size of the changes. Good programmers, they are trying to reuse. They're trying not to write too much. They're trying to take what's there and incrementally change a little bit. People who believe in rewriting, people who suggest that we need to rewrite the whole system because it was written wrong, these people are usually immature junior programmers. Senior programmers with enough experience, they know that rewriting from scratch is not a good strategy in most cases. It's better to do incremental changes where we move forward a little bit, reusing the code which was written before. That's why a large pull request is an indicator, very often an indicator of lack of skills, or maybe just lack of experience, which is sometimes means the same. some numbers. They're saying that open source projects, what's interesting, review smaller changes than proprietary projects. So in open source projects, people make smaller pull requests, and look at the year 2012, from 11 to 32 lines in a pull request. The number is interesting. It looks to me like a very low number, very small number, because I sometimes and very often see pull requests of over 100 lines of code or more, but the average is this. This means that it's good, maybe on average in the industry. And then they're saying the small size lets reviewers focus on the entire change, and then incrementally reduces preparation time and lets them maintain overall picture. So small pull requests are better because tons of reasons. We discussed them on the previous lecture. We can discuss it again here, but I think it's enough said about that. The smaller the changes, the more increments you make until you reach the final point, the better for everybody. For you as an author, for the reviewer. Your job as a reviewer is to reject large pull requests. That's my message to you in this lecture. Reject them. Big pull requests, no mercy for them. Ask them to rewrite. Ask them to break down, to decompose. But of course, again, remember, in open source, if you reject, people may never come back to you. So sometimes you need to make a compromise. Sometimes you will have to accept whatever is coming. 1,000 lines of code changed. You just say, okay, whatever, you accept it, and then you deal with that. But that should be an exception, definitely not a rule. Don't encourage people to make large changes. Encourage them to make smaller changes by rejecting what they did. Let's take a look at some more numbers from the same research. That was 10 years ago, quite old research, but still open source projects, they're quite large. You can see how many lines on average people commit in their pull requests, in their patches. Apache, 25 lines. Linux, 32 lines. Lucent is large in this project. 2063. And then Bing, 78. Chrome, Bing, 78 lines. That's the number. In this graph, look what you can see here. These are the projects, different open source projects, and these are the lines, how many lines changed per pull request. So the majority of pull requests are here. You understand the graph, I hope. But overall, the numbers are quite small. Or maybe I misunderstand these numbers because these are the averages, the means. And obviously, there are pull requests which have, 5,000 lines of code, and they exist. These pull requests, they do exist in each of these projects. And that's not good. Ideally, we should see 0 pull requests like that. Nothing. All pull requests should be within certain limits. And in my opinion, this limit is maybe a few hundred lines of code, ideally maybe 100 lines of code. And this is review intervals. Very interesting numbers as well to take a look. So how long it takes in different projects to review the pull request. What's the timeline? What's the time interval between submitting the pull request and then merging the pull request? So you can imagine how long it is. I'm surprised by these numbers because look at this. 17 hours, 14 hours, 15 hours. It's extremely fast in my opinion, which is good. Maybe again, maybe I am too optimistic about this. Again, on the horizontal line, we can see projects, and here we see interval in days. So you see 1 minute, 1 hour, 1 day, 7 days, 30 days, 1 year. So the pull requests which people review for a month, they exist. This is the 1 month review. And the black means, in this graph, sorry, I missed the explanation of what is red, what is gray. Not so important. What's important to see that some pull requests are being merged fast. Some pull requests stay longer and may wait for months. In my open source projects, I have pull requests which are waiting and hanging there for months, unfortunately. Not always I blame the authors. Very often I blame myself for that. I blame myself in the way that my repository is not prepared for a smooth integration of the changes or an effective rejection of that. I'm talking about continuous integration. So my robots, my automated tests, they should be working always great. So they should be stable. My tests, they should be stable in the master branch. And when something is coming, they should immediately indicate that there is an error. So I shouldn't have flaky tests. I shouldn't have broken pipeline. I should have a stable pipeline, and then it will be very easy to integrate pull requests. Unfortunately, making sure that the pipeline is stable is very difficult, especially when you have many projects. And I have many, more than 100 projects. And to keep in these 100 projects pipeline stable everywhere is extremely time-consuming job. I need to do it full-time. If I would be a full-time open source developer, then maybe I would be able to keep my pipeline clean in all of my projects. But that's impossible even to imagine how to do it. Because of that, people submit pull requests to me, and these pull requests are just hanging there because I cannot prove to them that what they did is wrong. I don't want, like I just explained to you, I don't want to do it manually. I don't want to demonstrate to them and explain to them that this code is not going to work. I want to show them the error log from the CI, but I can't because my CI is broken. My build pipeline is not stable. And I'm waiting until I fix that build pipeline. I'm waiting and waiting. While I'm waiting, their code gets expired because my changes in the pipeline lead to merge conflicts with their pull requests. And then eventually I have to say, sorry, please guys, I just fixed my pipeline. Now it's your turn. Now fix your pull request. But some of them already gone. Some of them already not interested in my product. Some of them already forked my repository and implemented their own releases. This is what happens, unfortunately. Your job is to try to make this review time as short as possible. And the ingredient number one for this is stable CI pipeline, stable build pipeline. Another reason for rejection I suggest to use is rejected if it lowers code coverage. One reason, obvious reason, the code is too big, which we discussed before. Another reason is if the code coverage goes down. This is very good, effective mechanism of protecting your code base against changes which are not defective, which are not wrong, but they jeopardize, they break in certain places your safety net, your unit testing setup. And this is what safety net is. Your unit testing setup is your safety net. This is something that defends you. This is something that protects your coding, protects your repository. When they commit something with not enough code coverage, they plant a bomb, a time bomb, into your repository. Eventually somebody will hit on this bomb and you will have troubles. You can legally, reasonably reject their changes by this particular reason. You can say, we in our repository trying not to lower the code coverage. What is code coverage? You can Google that. It's a very common term. This is the percentage of the code which is covered by unit tests. If they make it lower, you reject the code. You can use instruments for that. We use CodeCov, for example. CodeCov is a very popular hosted service for free for open source repositories. You just install it for your repository, and every time the pull request is coming, CodeCov will measure what is the coverage before the changes and what the coverage after the changes. Take a look at this. So they may say this is the main branch, 95%, and this is the difference. This is the branch 150, So the new coverage is plus 0.01%. So that is acceptable. That's why the line is green. But sometimes the line may be red. And if the line is red, you can say in the pull request that, hey, thanks for your contribution, but you know what? CodeCov is complaining. How about you increase code coverage? And people will understand that it's not you being a crazy dictator who is demanding some additional unit tests. It's just the standard. It's just something that you're trying to maintain in your repository. You're just trying to keep your coverage at certain level. The contributors, in general, it's easier for somebody to follow the law instead of following instructions. If you're saying that I need to do something, it's one thing. If the law is saying that I have to abide the law, I have to obey the law, then that's a different thing. It's way easier for me to obey. It's way easier for me to listen to the law than to listen to the dictator. So don't be a dictator. Just turn these dictatorship functions to the CodeCov server. Another recommendation, which is also, I believe, maybe very effective, reject the pull request if it doesn't reproduce a bug. So if what they made, and this is in general, I'm thinking how to present that. This is in general a very typical mistake of what programmers do. There are two types of mistake. The first one, they fix a bug. So they send you a pull request. In this pull request, you can see that they are, let's say, removing something from line number 7. That was a wrong, defective operation in line number 7. We have to remove it. So you receive the pull request and the line is gone. The line is removed. The question I ask to the author of such a pull request always is, how do you know that this helps? How do you know that removing this one line actually does make sense? That something better will be with my repository after the removal of one line? Sometimes they say, I don't know, I hope. Then obviously you reject this pull request. Another answer may be, I checked it on my computer. So I ran this code on my computer and it did help. That's a better answer. But still, it's not a perfect answer. Because my next question would be, how do we know that tomorrow somebody else will not insert line number 7 with the same content there, and we're not going to know about it because there are no tests that can catch us. When a bug is being fixed, it is important to understand that the root cause of this bug is not the programmer who put this line number 7 there. It is the programmer, not even the programmer, it is the unit testing setup, all the unit tests together that are not strong enough to detect that line number 7 has a wrong statement. This is what we have to fix first. You have to fix the unit tests. Maybe write a new one. Maybe fix the existing one. Maybe configure the existing one. I don't know. But improve the unit tests. Improve my safety net, which will catch this problem, which will indicate, highlight the problem in line number 7. And then you remove line number 7 and commit these two parts together. The test, which reproduces the bug, and the bug, which is fixed. In ideal setup, and I told you about that, you have to submit 2 pull requests. The first pull request will be the fix of the tests. So you introduce new test, which is broken, which will be red, which is not going to pass because the line 7 is not yet fixed. But you disable that test and commit it and submit me a pull request. And in this pull request, you will say, I managed to reproduce an important bug. The bug is still there. That's why the unit test is disabled. I review that. I see the logic of your unit test, and I will accept it. The next pull request, you fix the bug. You remove line number 7 and you enable the test. So you remove the annotation or whatever you use there, so the test becomes green. 2 pull requests. That is ideal approach. Less ideal is when you're coming with the 2 parts in the same pull request. The test is changed, improved, and the line number 7 is deleted. But if you're coming only with the line number 7 deleted, then my first question is, how do you know there was a problem? And how do you know the problem is gone? None of these answers are answered. None of these questions are answered. And I definitely will reject such a pull request. So that's one type of the mistakes. Another type of mistakes is when you're not fixing the bug, but you're introducing new feature. You're sending the pull request, not you, but I've seen people doing that. They're sending me the pull request, and in this pull request there is a new feature. There is new implementation. And again, no unit test. So there is no reproduction of the bug. The absence of the feature is still a bug. We discussed that about discussed that philosophy, that mentality about bugs. Anything that is not implemented right now is a bug. If your code doesn't have a feature and I need this feature or user needs that feature, it means that the code has a bug. So treat the situation as a bug. So you fix that bug, you implement this feature. But my question is still, how do you know that you reproduced the problem, which is the absence of the feature? You have to reproduce, you have to prove to me that the code you wrote actually works, actually goes through some testing system. Either upfront, so you test it upfront and you prove that it didn't work before, or afterwards when you implement the code, but still you need to cover it with the test. It's a very typical mistake many junior programmers are making. They're making changes, but they don't write unit tests. While good programmers, professional programmers, they first commit unit tests and they commit the changes. Unit tests, in general, in projects which are more or less mature, are more difficult to write than the code. Unit testing in general, writing unit testing is a more professional, more difficult, more time-consuming and brain power consuming activity than writing the code that works. So if you are not a junior programmer, you understand that first you need to do tests implementation, then you do the rest. When the request is coming without reproduction, without a unit test, it's definitely a reason for rejection. And finally, we have 2 more. So continuous integration. I said about it a few times already. You need to understand that, of course, in order to be a good reviewer, you need help. You need support from your CI system. If you have continuous integration system, if you have checkers which help you highlight the problems in the coming pull requests, then that will help you a lot to explain your reasons for rejection to the authors of the code which is coming to you. You have to rely on that status. You can rely only if you trust your CI system. If your checkers are not stable or not as stable as you expect them to be, for example, they're flaky, sometimes CI status is red, sometimes it's green, but it's out of your control. Of course, it will be difficult for you to reject pull requests because the authors, they will blame your CI, they will blame you, they will just say your tests are broken. I wrote a good code, it's your tests that do not allow my beautiful code to pass. And remember how we started this lecture. You, a reviewer, and me, an author of the code, we are on the opposite sides of the fence. You fight with me, I fight with you. You are trying to defend, to reject. I'm trying to push it through. In order to maintain this mentality, I would recommend you to think that way. Imagine that you are being paid for every pull request that you submit and it gets merged if you're the author. You submit it, we merge it, you get the money. First. Second, you report a bug, you tell us what is wrong, you get the money. This is your second source of income. And your third source of income, you make a comment, a negative comment, on a pull request. 3 sources of income. If you think like that, then you will way better understand the dynamics of software engineering. Instead, if you think that you're getting money by the end of the month, then it will be hard for you to understand the dynamics of software engineering. So think as a person who gets money for these 3 contributions being made. Pull request merged, issue submitted and accepted as a bug, and number 3, a comment made on the pull request. Look at these interesting findings which were done just last year. That's what they're saying, that GitHub Actions, when they exist, it leads to more rejections, and it leads to more time to accept a pull request. There are many things actually. More rejections, more communication in accepted pull requests, less communications in rejected pull requests, fewer commits in accepted pull requests, and more commits in rejected pull requests, and more time to accept a PR. So all of this looks like a lot of negativity about GitHub Actions. A lot of things which may be understood as something which we don't want to see in our repositories. We don't want to spend more time, we don't want to see more rejections. But if you think deeper, none of these things are saying anything about quality of code in the end. So yes, it takes more time. Yes, we talk more. Yes, we reject more. But this is good. These are the ingredients of quality. In order to achieve higher quality, we need to suffer. We need to pay for it. And we pay with what? With our communications, with our time. Of course, if we completely remove GitHub Actions, completely remove code reviews, completely remove unit tests, we're going to just push our changes to the master branch. Everybody will be happy for a while until we start thinking about quality, start thinking about downtime of our system, start thinking about our customers. At that point of time, we will understand that we paid nothing for the quality. We invested nothing. We didn't suffer at all during the preparation, during the coding. We were so happy. It was so easy to just push our changes there, no barriers. In the end, the product will go down to the drain. So the more troubles you put in front of the programmer, the more troubles you're gonna insert on the way from laptop to the code repository, the better. You, a code reviewer, is one of the troubles. You're one of the main troubles should be. Well, the main trouble should be, of course, unit tests. So don't try to replace unit testing system with yourself. Like I said before, if you see that you have to manually explain to the author what's wrong with the code, it means that the CI is not strong enough. The testing framework is not strong enough. Don't go into explanation. Fix the CI first. But of course, we cannot make the CI perfect. We cannot make all the tests absolutely excellent. There has to be some space for manual intervention. So for manual review, for manual inspection of the code, for subjective inspection. Something is not to my taste and something looks not as elegant as I would love to see. This is something that no tests can check. That's why we need people for the fine-tuning of the code, but not for checking the code for serious runtime defects. Definitely not. And of course, the final point, as you may expect, ChatGPT is definitely a potential, maybe a replacer of the code reviewer. So we're definitely looking into the future and understanding that code review will be, if not completely eliminated, if not completely replaced by robots, but a large amount of work will be done by computers. Programmers will send code in, and computers will do a lot of analysis, will provide a lot of criticism, a lot of suggestions, a lot of corrections, and that's good. It's inevitable, it's going to happen, it is already happening. It starts to happen, because I haven't seen a solution so far which would do this, what I'm saying. They must show up on the market, but so far we don't have them. What we have now is something that I showed you on the previous lecture, which we use. It's a very simple, easy to install solution. It's called PR Codex. It's based on ChatGPT. Every time the pull request is coming, it explains to me as a code reviewer, it explains what the code is doing there. It helps me as a code reviewer, but it doesn't say what's wrong. It doesn't suggest any corrections. It just explains what's happening. It helps, but not so much. You should be prepared for a way more powerful LLM-based solutions, which will be correcting the code coming from programmers, criticizing them, making very detailed analysis of what's going on there. They will even pay attention to who is making the commits. They will say, hey, we know this guy. He made 5 mistakes last month in another repository, and also he contributed this pull request to another repository, and because of that pull request, they got that amount of failures there. Just for your information. And this guy is now committing to your repository. That will be the future. Is it going to be a good future, or it's going to be a not so bright future? It's hard to say, but definitely robots will replace us. Now it's time for you to think how you will be better than robot. What kind of review you will provide to the authors, what kind of information you can provide that the robots cannot provide. And that you can start thinking right now. As a code reviewer, you have to be like they said, the mentor. You have to be like a teacher. You have to be like a friend. You have to be like a supervisor, like a prosecutor, like a judge for this code. But first of all, before you become a judge, before you become a prosecutor, you have to be a mentor. So you have to know enough. You have to be knowledgeable to share the knowledge together with your criticism. You criticize and you support this criticism with the knowledge. That's the recipe for success. That's how you not spread negativity in your repository. By being knowledgeable enough about your suggestions, about your repository, and about your principles, which you try to enforce, and you'll be fine.